Good morning, my name is Ko Teng Sin, and today I'm going to present my video assignment. So, for my first question is question 2a. A crane as shown in figure 4 is used to lower weight into the sea, which have density of 1025 for an underwater construction project. The dimension of the rectangular block is 0.4 meter times 0.4 meter times 3 meter, and the density of the concrete block is 2300. Both of buoyant force of the air and the weight of the rope are negligible. So, for the first question, we are required to determine the tension in the rope of the crane when the concrete block is suspended in the air. The block has a volume of 0.4 meter times 0.4 meter times 3 meter, which is 0.48 meter cube. So it has a mass of 1104 kg. Therefore, the tension in the rope when it's out of the water is m times 3, which is 1104 times 9.81, and we get the number of 10.83 kilonewton. Consequently, we are required to determine tension in the rope when the concrete block is completely immersed in water. In the water, it is displaced 0.48 meter cube of water, which has mass of 492 kg. So the tension in the rope when it is in the water is mass block minus by mass of water times G, which is 104 minus 492 times 9.81, which we get the number of 6 kilonewton. So for the question to be, the question is 80 cm high aquarium with cross section of 2 meter times 0.6 meter that is partially filled with water as shown in figure 5. The aquarium is to be transported on the back of a truck. The truck accelerates from 0 to 90 km per hour in 10 seconds. Assume the acceleration remains constant and maintained in horizontal. So in the question 2b, the given data height of the tank is 80 cm, cross section of the tank is 2 meter times 0.6 meter, initial velocity of the truck will be 0 km per hour, and the final velocity is 90 km per hour, which is 25 meter per second, and lastly the t is 10 seconds. So for the b, we divide by 2 and we get the b2. So for the first question, in order to solve the question 2b1, we calculate the acceleration of the truck first, which is ax equal to 25 minus 0 divided by 10, and we get the 2.5 meter per second square. And we calculate the angle tangent theta, and we get the theta over here. And then we write the relation between zs and b, which is tangent theta equal to zx minus by b divided by b divided by 2, and we substitute the values in the both equation, which is tangent 14.3110 equal to zx divided by b divided by 2, and we get this value. And now we calculate the zs from the b, and the b is equal to 0.6, and we substitute inside, and we will get the zs equal to 0.0765 meter. And now we calculate the allowable inertial height, which is h equal to h minus zx. Zx is calculated here, so we just substitute everything inside, and we get the h equal to 0.8 minus by 0.0765 meter, and we get the height, which is 0.723 meter. Next, to minimize the risk of the water spill out from the aquarium, would you propose the tank to be aligned with the long side or short side parallel to the direction of motion? So we will calculate the zs for b equal to 2 meter. Zs divided by 2 equal to 0.12755 meter, and after we take the 2 and times it, will become zs equal to 0.2551 meter, and we substitute the value in the equation again, which is h equal to 0.8 minus by 0.2551, and we get the 0.5 0.54494. So for the recommendation, I would recommend that the tank to be aligned with the short side parallel to the direction of motion, because the allowable inertial height is greater than the long side. Now that's all. Thank you.